Today we are going to discuss the naming and we'll continue with the carboxylic acids. Let's see what are the naming of carboxylic acids. Ketones. In the last class we have aldehyde and ketones. So today we're going to have the naming of carboxylic acids. We told you the general formula is CnH2nO2. Functional group is C double bond O and then OH. And then we had few structures from carboxylic acids as well. Today we are going to see their IUPAC names for this. Systematic names for these carboxylic acids. So let's see what are the systematic names. Right, so systematic names of carboxylic acid are, please pay attention. For example, CH3, CH, CH3, CH2, and then COH. You know, in case of carboxylic acids, we just have to select the longest chain containing COH. And just like aldehydes, we do not need to mention the position of functional group in the name of carboxylic acid. Why we don't need to? Because they are always at the terminal carbon. So 4 carbon. And the second thing which we have to change is we have to replace E with oic acid. Okay. So butane is the 4 carbon alkane. So it will become So oic acid ka aapko position you are not supposed to mention. And what is this? This is 3-methyl butanoic acid. Okay. Similarly, if you look at this, CH3 twice, CH, and then COH. Please name these compounds. Yeah, 3 is 2 carbon. Na? You can have it, like structure. कोशिश करें मैं बताता हूँ or it's just dimethyl. If there are 2 carbon, can't be methane. So di you have to add before oic. Ethan dioic acid. Ethan dioic acid. So this is ethan dioic acid number 2, 1, 2. So there are 2 COH. So this is ethan. We do not need to mention the position. Why? They are at the terminal always. End वाले जो होते हैं. Number 3, please. You say not be sure that. Oh, so this. 1, 2, 3. 2. This is 1, 2, 3. Yes, it's a propanoic acid, but carbon number 2 has 2 methyls. 2 dimethyl propanoic acid. So
It's the same things.
Yes, number 4 is again ethyl dioic acid. There is one here which we have to name it.
It's 2-methyl propanoic acid.
Because this is CH and two CH3s attached, one on this side, one on this side, and this is COOH. So what will be the name? 1, 2, 3 propanoic acid, 2-methyl propanoic acid. Okay, the next is esters. The next functional group is esters. Acids are the organic compounds with the general formula the same as carboxylic acid, which is CnH2nO2. Their functional group, although, is a different, as they are the different organic compounds. Look, COO should be R. R mean carbon chain. So this is what we say should be COOR. This should be the functional group for the esters.
C. OH is
Okay, molecular formula. Just like alkenes, just like ketones, there is no one carbon ester. All those who have done O levels, they know that we learned in O levels that carboxylic acids and alcohols, two group of organic compounds combined to make. So esters cannot be one carbon, because if minimum one carbon from carboxylic acid, one carbon from alcohol comes, they can't have one carbon ester. Yeah, so minimum numbers for first member of ester group is C2. C2H what? 4O2, the molecular formula. Then C3H6O2, and then C4H8O2, right? If you draw the displayed formula, once you are drawing displayed formula, I would suggest to you that when you are drawing esters, you have to write first of all the functional group. Okay? Don't write the chain first. First write the functional group. Functional group C double bond O, and then O, and there must be carbon with the oxygen, right? So I have to put one carbon here with the oxygen. And I already have total number of carbons. दो ही carbon थे ना? So this is 2 carbon ester. So what I'm saying that oxygen के साथ you have to put carbon. So this is HCOO and then CH3. If you write the structural formula, it becomes HCO2 and then CH3. If you write the skeletal, it's a bit tricky that you write a carbon with double bond O. There is the oxygen, and here is CH3.
So if you not write a skeletal.
Yeah. Printing. Okay, can you please draw C3 wale displayed structural and okay, C3, let me do it. First, I told you draw C double bond O, O. And then as I have to put one carbon next to O. Right, so how many now? One more to go. So I can put in either side. This time I'm going to put on the back side. Will be an ester, obviously different, but at this moment we are just trying to make any ester. So here it is. Now, if you write the structural CH3, CO2, and then CH3. And if I write the skeletal, look, C double bond O, then O, and then C. Okay?
So skeletal.
Skeletal mein just oxygen comes in the chain in the ester. So ester could be easily recognized. The oxygen is shown inside the chain.
How do we know how to make like the second carbon chain skull?
I think no, it's at this moment you can put anywhere. Like this carbon you can put here as well. No, structure में I just followed this ना, because this is the skeletal में मैंने इसी को follow किया है. ये CH3, ये CH3 है, and then this is the carbon, then oxygen, and then this is the carbon. Okay, I followed this. Got it? Skeletal is just following this. Look, pay attention. This is the carbon, na? So I put a dot instead of carbon. Then there is a carbon with the double bond O. Then who is next? Oxygen. And then there is a carbon again. Got it now? Okay. Is it so? Got it? Okay, next. Yeah, that's how the ester, one thing which I would like you to understand, that if I have this ester, look at this. This is the ester. I can write like this. CH3, CH2, and then these two oxygens I can write CO2 and then CH3. So you will see the ester written as CH CO2. But if I invert this and write it, like if I write CH3 before and then O and then CO and then CH2 and then CH3. So please do remember OCO is also the functional group of ester. Okay, don't confuse because at times examiner put it like this. So when it is OCO, you will understand it's an ester, but the oxygen part, the alcohol part that is written before. That's why it is OCO. So at this moment, just keep in mind that OCO is for esters. Okay? Right, next. Next is yes, next is no, the two more functional groups. Please write down. Next is nitriles. We are done with the esters and carboxylic acids. Yeah, sorry, if as far as the naming is concerned. Yeah. Look, as far as the naming is concerned, please pay attention. When you name the ester, how you name them, look at this. Yes, I'll send the notes on group. इधर देखें, इधर देखिए. So if you name this ester name is always divided into two parts, बच्चों. Please pay attention. The two parts are this one and this one. This is the part that comes from CO. ये part है, ये कहाँ से आता है? So you have to add O8 with it. So how much O8? Propanoate, because 3 carbons. And this part comes from alcohol. This is what? Aryl. So no, methyl propanoate. Okay. So this is the only naming of esters. Yeah, nothing more than this. Just whatever. Okay, next. The next functional group is nitriles. Nitriles are the organic compounds with functional group CN. Okay, next. Nitriles. The next is nitriles. Please pay attention. Nitriles is the CN H2N plus 1 CN is the general formula. The functional group is C triple bond N is the functional group for the nitriles. Please. Minahil, please. Aisha, I'm sorry. Okay, so the first member, please pay attention. The first member of nitriles cannot have one carbon, minimum because they need two carbon, just like esters, just like alkenes. There is no one carbon nitrile. So pehla member is this CH3CN. Okay, so if it is CH3CN, and you can also write it CH3CN. And if I write in the skeletal form, look, this is, there are two carbons here, and this carbon also contains triple bond like this.
So do we have to show the triple bond?
Yes, you have to show the triple bond and then N attached with this. Yes, there are two carbons. Here is one carbon, here is another. Okay. Similarly, if there are three carbons, oh sorry, this is known as ethane nitrile. And there are how many carbons with this? This is what? Propane nitrile. That includes always when you name. So total carbon you have to count. How many total carbon? Three. So it is propane. Okay. So if you draw the skeletal 1, 2, 3 carbon, first I wrote 3 carbon and then I put triple bond like this. This is propane nitrile. This functional group is actually in A2, but at times their products are formed. That's why I just told you a little thing about it. Not more than this. The next functional group is amines. Can I have some silence, please? Please. Amines. The general formula for amines is CN H2N plus 1 NH2 and functional group is NH2. Okay. NH2 is the functional group for amine. So first member is with the one carbon like this. So you call it methylamine. There are two carbon and then NH2. What do you call it? Ethylamine. So it is CH3NH2. This is, and similarly propylamine, but that's enough. As I told you, these are the functional group in A2. I just wanted to let you know that this is also the functional group because at times in organic chemistry in A,
Do we write like wire with the
Oh, alcohol, yeah. Okay, so that's all about this. Now, one thing which I have to tell you, this is all the function groups which you have done with the naming, but there is a one more. Please pay attention. Uh, Pay attention, please. If I cyclic organic compounds, now please pay attention. What are the cyclic organic compounds? Now, for example, let's start with alkane. Now, please pay attention, everyone. Can you see what is this compound? It's an alkane. And how many carbons? So it is C3H8 and known as propane. Now, what the organic compound has special ability that whatever the length of carbon chain is, obviously 3 or more, not less than this. What they can do, their two ends, look at these two ends. They are flexible enough that they're, for example, if this is the long chain, look at this cable. If this is the organic compound, this much chain is length. What they can do, they can turn around and bond the two terminals together. So what is the change? Only change is that that straight compound, an aliphatic straight chain, will turn into cyclic. So there is no other change in its properties. Just functional group remains the same. Everything remains the same. Chemical properties are the same. It just turns into a cyclic compound. Obviously, it becomes different from that. What I'm trying to say that if I take off these two hydrogens from propane and these two carbons make a bond with each other, so it will turn into C3H what? 6. And it's no more a straight chain or aliphatic. Aliphatic कहते हैं straight chain को. Aliphatic alkane. It is now cyclic alkane, and you call it not propane, rather cyclopropane. And how you show it? Because you have to hammer the two carbons on the terminal, get down and close to each other to make a bond, right? So you have to show like this. One carbon here, one carbon here. Now, as they have to lose these two hydrogens, so how many hydrogens left with the terminal carbons now even? Two. And center one ke paas to pehle hi how much hydrogens it has? Now all three, there's a phenomena, there's a catalyst, there is a conditions for that, right? At this moment, we are not going to discuss, but these are the conditions. So these are the two hydrogens, right? So this is CH2, CH2, and CH2, right? You can write it like this. Yes, so it's a, और जितने कार्बन होंगे वही geometric shape होगी. जैसे 3 carbon has what geometric shape? Triangle. So if you draw it in skeletal, so it looks like this. Okay, and this is known as cyclopropane. Okay, इसमें बस ये ध्यान में रखना है कि जो alkane था, 2 hydrogens are less. 2 hydrogens now कम हो गए हैं, right? So the same alkane turns. So properties are the same, the chemical properties, right? Obviously, it's another compound from propane. It's not the same compound, but the chemical properties are just like alkane because the function group is the same, right? And this is the first member of cyclopropane. What will be the second member? How many carbon atoms in the second member? Yes, so it will be like this: 1, 2, 3, 4, and every carbon, how many hydrogens? How many hydrogens with every carbon? 2. So how you write it? CH2, CH2. So all the carbons in the ring are CH2. And if you write the skeletal, it will be like this. And what is the name of this compound? Cyclobutane C4H8. So they may look like alkenes because their hydrogen number is just like alkenes. Okay. Number 3, if there are 5 carbon in the chain, so they will look like pentane. You have to draw the both structures. I'm just drawing the skeletal one. This is pentane. Please draw the displayed and structural. And the last one is cyclohexane. These are in our syllabus only. Please draw the structural and skeletal. This is cyclobutane. This is cyclopentane. And this is cyclohexane, right? If you look at the general formula, so it is CnH2n, okay? And this phenomena is not only limited to alkanes. Yes, they can also with alkenes. For example, cycloalkenes ka Jenner formula kya hoga? Just subtract two hydrogens. What was the Jenner formula for alkene? Now two hydrogens subtract kar denge to kya ho jayega? Yes, CnH2n minus 2. Functional group to wahi rahega. What is the functional group? Carbon-carbon, double bond. Okay. Now the first member, 3 carbon cyclic hona chahiye na. The first member will be what? Cyclopropene. So wahi 3 carbon bana diye, but there is a 1 carbon with what? Double bond. And these 2 carbons which are having double bonds, I hope you understand, they are not CH2s. They are now what? CH. And this is CH2.
Where do we write the CH and CH2?
No, I just wrote it to show you that it is CH2 like this. So jahan bhi double bond hoga, we have to understand that there is a double bond, so it means carbon has only 1 hydrogen at this. This is what? Cyclobutene. This is what? Cyclopentene. This is what? Cyclohexene. That's so on. Alcohols, aldehydes, everything can have the cyclic structures like that. Okay. That's the only information which you need at this level. That the organic compounds, when their terminal carbons turn around and make a bond, so the same turn into a cyclic compound.
Even in detail, I don't over detail.
Zishan?
इसका जो नेम है हेक्सीन होगा.
Cyclohexene. That's his cover. Test. Okay, next. Please pay attention. So the one which I'm going to write here, you have to follow this pattern and make a table. That's your homework. I'm just going to give you a demonstration. This is your homework, okay? इसमें ये अभी तक जो हमने किया है, basically I'm trying to summarize that, and in this summary you have to write these headings, and this is your homework. But first you look at the table. You may have to rotate this notebook by 90 degrees. So look at this. For example, here is the group. For example, first group which we did was alkane, right? You have to write FG mean functional group, as the alkanes do not have any functional group, so just cross. Then general formula you have to write for the alkanes. What was general formula? CnH2n plus 2. And then the next you have to write molecular formula, first 3 members, any first 3 members of the group. First three members. For alcohols, the first member is what? CH4, the molecular formula. Then, right? And then you have to write skeletal formula. C4 to C6. Three members skeletal formula. C4 to C6. Like in case of alkane, you can write the skeletal formula for butane, pentane, and hexane. But keep in mind, one should be the branch structure. For example, for 4, I write straight. For 5, I can write in the form of branch. ये 5 carbon है जिसमें 4 straight chain में and 1 is in the branch. और फिर 1, 2, 3, 4, 5, 6. Right? So these are 3 different compounds. Na? So you have to draw the skeletal formula for 3 compounds. Right? So this is your homework. But this is your homework. Look. Now, for alkanes, I did. For the rest of the groups, you have to do it. Okay, and which are the groups? Number 2, alkenes. Please note down now. Next is what? Alkane. Cycloalkene. No, इसके haloalkanes. Then it was alcohols. Then it was aldehyde. Then it was ketone. Then it was carboxylic acid. Then it was ester. And then nitrile. And then amine. No, no. So this is the summary of the stuff which we have done up till now. So that's your homework, okay?
Thank you.
Okay, the next is Gigi. You just have to write the names of the functional groups only. Yeah, इसको group पे डाल दें. Okay, you don't need to copy. You can copy from the. Is there on the group, please? Nitrite and amine. Okay, so from naming, we are moving on to the next step is the isomerism, right? So please give heading isomerism. Isomerism. So please pay attention now. We have a bit of it in O-level. It was just kind of introduction. Over here, we have a detailed topic in which we'll see all the different types of isomerism, right? So there are two, please write down, there are two main types of isomerism. Number 1 is structural isomerism. And number 2 is stereoisomerism. Number 1, please give heading structural isomerism. the compounds having same molecular formula but different structures are known as structural isomers. And phenomena is known as structural isomerism. And this phenomena is known as structural isomerism. This phenomena is known as structural isomerism. There are following types of structural isomerisms. Okay, now please pay attention. Okay, first let me let you write this, then I'll explain. Number one, chain isomerism. Yes. Number two is position isomerism. And number three is functional group isomerism. No, let me explain. I'll let you write the next part in the next class, but now I'll take these few minutes left to explain this. So please, I would like you to stop writing. Don't write anything beyond this point. Please pay attention now. Look, if I have a compound C4H10, this is the molecular formula of a compound, looks like an alkane because the hydrogen number is double plus 2. And if I write a structure for this like this, is this C4H10? Yes. Okay, if I look at the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here that, right? If I draw the same organic compound, but instead of putting 4 carbon in the chain, I put 3 carbon in the chain and the fourth one in the form of a branch. This is again C4H10, but these two are the different structures. One is butane, one is 2-methyl propane. So my question to you is, what do you think? Are these the two different compounds with one molecular formula, or are these two different structures of one compound? This is what the misconception which carry on from O levels. These are two different compounds. They have one molecular formula. I give you an example. You go to petrol station, you buy the petrol of like normal octane, and then there is another dispenser next to that which is having high octane. You know, both of them are C8H18. So both of them have the only difference, the one which we buy, normally I buy, the cheaper one, that is the one with the 8 carbon in the straight chain, right? On the other hand, the one which you guys buy, the rich people, the one with the high octane, so that is the one which is the branch. So 5 carbon in the chain and rest of the 3 are in the form of branches. So these two, what I'm trying to say, that one misconception that you must not have anymore, that structural isomers, the two different structures, these are the two different compounds with different. Now, what is the difference in the structure at this moment? The difference in the structure is what? Number of carbon in the chain. इसकी chain में कितने carbon है? 1, 2, 3, 4. उसकी chain में कितने carbon है? 3. इसको कहते हैं chain isomers. So when the compounds differ, have a different structures, and the structures differ by means of number of carbon in the chain, it is known as chain isomer. So structure कैसे differ कर रही है ये भी बताना होगा. You can't simply say the structures are different, right? But in another case, if I tell you C4H9Cl, look at this. 1, 2, 3, 4 carbon in the chain, and here is the chlorine attached. This is 1-chlorobutane. There is another compound with the same molecular formula, but Cl is attached at carbon number 2. This is called what? 2-chlorobutane. Now, look at this now. These two are the two different structure, but the number of carbon in the chain are now same. 4 carbon in the chain in the both compounds. So what is the difference now? Yes, position of functional group. Here is the position is what? 1-chloro. And what about the position in this? 2-chloro. So now and again, are these two different compounds? Yes. So these are the two different compounds which have the different structure. The only common thing is their molecular formula. When you have this kind of cases, this is known as again a structural isomer, and precisely it is known as position isomers. When the structures differ by means of position of functional group. How the structures differ, we have to tell. When the structures differ by means of number of carbon in the chain, known as chain isomers. When they differ, when number of carbon in the chain remain the same, but they differ by means of position, this is known as position isomer. In another case, for example, C4H8O2, for example, 1, 2, 3, 4, OH. So it's a carboxylic acid. 1, 2, 3, 4, it's an ester. So what is the difference now? These two structures differ by means of what? Functional group. One functional group is the ester and one is, this is ester. What is this? So both of them has same molecular formula. So when the structures differ by means of functional group, they are known as functional group isomers, right? So these are the three different types in which the structures could differ, right? Structures could have a different number of carbon in the chain, known as chain isomers. Structures could have different number of position of functional group with the same number of carbon in the chain, position isomer, and the structure could have a different functional group, and they're known as functional group isomers. So हमें देखना होगा कि structures कैसे differ कर रही हैं. Okay, we'll continue. Tomorrow we'll have more examples and the definitions for these as well. Thank you very much. That's all.